Lasers. Hello. Again, I am Saranga Bandara from the Open University of Sri Lanka. In this short video, I am talking on lasers. Lasers. Light amplification by stimulated emission of radiation. The Einstein relation gives a mathematical relationship between three transition processes: absorption, spontaneous emission, and stimulated emission. The ratio between the stimulated emission rate and the spontaneous emission rate are given as the equation. When the system is in thermal equilibrium, the rate of spontaneous emission is higher than the rate of stimulated emission. Hence, the emitted rays will be incoherent. To produce coherent rays, the rate of stimulated emission should be greater than the rate of spontaneous emission. For that, in a system, the radiation density and the population density of the upper energy level should be increased than in the lower energy level. It can be achieved through a non-equilibrium distribution through a population inversion. At room temperature, under normal conditions, the atomic structure is in thermal equilibrium. It means the density of atoms at lower energy levels is higher than at the higher energy levels. In a non-equilibrium condition, it should be inverted, such that the density of atoms at a higher energy level should be greater than in a lower energy level. So it is called as the population inversion. The non-equilibrium distribution of atoms can be achieved by exiting the atoms into the upper energy level, using an external energy source. And this process is known as pumping. When population inversion occurs, the lasing process will be caused by transiting the atoms from upper energy into lower energy state, due to the incident of an external photon. Hence, through population inversion, optical amplification can be achieved. There are three main injection laser characteristics. 1. Threshold current. 2. Dynamic response. 3. Noise. Threshold current. The stimulated emission of the material will start when its current exceeds the threshold current value. Threshold current is a temperature-dependent factor. When temperature increases, the threshold current value also increases. The threshold current density increases exponentially when the temperature increases. Dynamic response. Theoretically, when the current exceeds the threshold value, the device should start the laser process. But even when the supply current exceeds the threshold current value, there exists a time delay for the laser process. The time delay is known as the switch-on delay. The switch-on delay was followed by the high-frequency damped oscillation, known as relaxation oscillation. The switch-on delay lasts for a few nanoseconds, while relaxation oscillation lasts approximately twice of switch-on delay. The relaxation oscillations are due to the variation of electron density, such that it repetitively increases and decreases over that time period. At high bit rate optical fiber communication systems, this dynamic response of the injection laser will considerably affect the pulse shape. Hence, the switch-on delay and relaxation oscillation should be reduced. The switch-on delay can be reduced by biasing the laser near threshold. Noise. Phase or frequency noise is a common noise for all types of lasers. Because of phase noise, the output of the single frequency laser is not perfectly monochromatic. The phase noise will be caused due to the variation in the intensity of the emitted laser. That was a brief introduction to lasers. We will meet with another short video soon. Till then, thank you and bye.